All right, so we're looking at your earthquake quiz, and as per usual, if you need to go slower, you need to go back, then you need to make sure you are pausing and doing that. There's going to be some opportunities for you to be looking at your reference table using your graph. I expect you to press pause on this, to go over, look at your graph, do that, do whatever you need to do. So that you have the right amount of time to do it, okay? I would suggest at this moment, open your reference table up to page 11. I will send over a PDF copy of the reference table just in case you don't have your copy at home, but you should. All right, so you're going to need page 11 multiple times. I would also grab yourself either a sticky note or probably multiple sticky notes, or a little thing of index cards, a little piece of paper or something, because you're going to need to be able to mark your little sticky note or whatever to use on your graph. All right, so let's start with number one. Number one, Earth's inner core is inferred to be solid based on the analysis of what? So how do we know that the Earth's inner core is solid? A, seismic waves. B, crustal rocks, C, radioactive decay rates, or D, magnetic pole reversals? How do we know that the core is solid? Okay, number two. You have this diagram below. It shows models of two different types of earthquake waves. So we know that those are P waves and S waves, right? If you don't know which is which, you're going to have to figure that out. The difference in seismic station arrival times of the two waves represented by the models help scientists determine the what. What can you figure out when you know the difference between P wave and S wave arrival times? A, the amount of damage caused by an earthquake. B, the intensity of an earthquake. C, the distance to the epicenter of an earthquake. Or D, the time of occurrence of the next earthquake, when the next earthquake is coming. Number three. The first P wave of an earthquake took 11 minutes to travel to a seismic station from the epicenter of the earthquake. What is the seismic station's distance to the epicenter of the earthquake? And how long did it take for the S wave to travel that distance? So you're going to look at page 11 on your reference table. Find where the travel time of the P wave is 11 minutes. Okay? Once you figure that out, you should be able to figure out the distance to the epicenter and the S wave travel time. Okay? Travel time of the P wave is going to be 11 minutes. Number four. We've got this whole graph here, but essentially what this question is asking you is what is the minimum number of seismic stations needed to locate most earthquake epicenters? How many stations do you need to have readings from in order to figure out where this epicenter is? Okay. Another way to think about this is when you're looking at these maps that they give you with all the interlocking circles, how many circles would you have to draw to find one point where they all meet? Right? So is that going to be 1, 2, 3, or 4 stations or circles? Number 5. Base your answer to the following questions on the map and the modified Mercalli scale shown below. The map shows the intensity of the earthquake that occurred slightly southwest of New Madrid, Missouri in December 16th of 1811. The epicenter of this earthquake is represented by little asterisks right here. The Roman numerals on the map show zones of the earthquake intensities determined by using the modified Mercalli scale. Okay, so the intensity numbers shown on the map were determined by what? What are they using to rank the levels on the scale? Okay, so they have things like, not felt except under unusual conditions. Oh, well, some furniture's moving, plaster's falling, most ordinary structures are destroyed, so it just gets more and more severe as you go down. So what's being shown on this? A, the arrival time of the first P wave recorded at each city. B, the recorded time difference in the arrival of the first P wave and S wave at each city. C, observations made at different locations during and after the earthquake. Or D, observations made only at the earthquake epicenter. Number 6, a P wave takes 5 minutes to travel from the epicenter of an earthquake to a seismic station. Approximately how many minutes will it take an S wave to travel that same distance? So look on your graph at page 11. Find where the travel time of the P wave is 5 minutes. Okay? How many minutes would it take an S wave to travel to that same distance? Number 7. We have some seismic stations here. We have station X, station Y, and station Z. The distances from X and Y to the earthquake epicenter have been drawn on the map, but Z's distance is left out. So basically, this doesn't have a ton to do with this picture. It says compared to the speed of S waves in a given earth material, the speed of P waves is going to be what? Slower, faster, always the same, or sometimes slower, sometimes faster. So even just looking at your chart. Okay, does the P wave get there faster, slower, what? Same time? Question 8. The diagram below represents 3 seismograms showing the same earthquake as it was recorded at 3 different seismic stations A, B, and C. Which statement correctly describes the distance between the earthquake epicenter and these seismic stations? So think about the relationship between travel time and distance from the epicenter. Okay? So you're first going to decide which one is closest to the epicenter. So A, B, or C. And then decide which one's farthest from the epicenter, A, B, or C. Okay, and then decide which one's closest, which one's farthest. Number 9. If a seismic station is 3,200 kilometers from an earthquake epicenter, what is the time needed for an S wave to travel from the epicenter to the seismic station? Okay, so if the epicenter distance is 3,200 kilometers, what is the travel time needed for that S wave to travel to the epicenter? Okay, number 10. What is the direct cause of most earthquakes? What causes earthquakes? A, movement of bedrock along a fault line. B, the gravitational pull on bedrock by the moon. C, the deposition of sediment in lakes and oceans. Or D, a heat exchange between the crust and the atmosphere. What's causing earthquakes? Number 11. A seismograph station recorded the arrival of the first P wave at 7:32 p.m. from an earthquake that occurred 4,000 kilometers away. What time was it at the station where the earthquake occurred, or when the earthquake occurred? Okay, so the arrival time of the first P wave is 7:32 p.m. The epicenter distance is 4,000 kilometers. So you're going to look and you're going to subtract the travel time from the arrival time. Okay, so you have to look, where is the epicenter distance? 4,000 kilometers, and what's the travel time of that P wave? Subtract the travel time from the arrival time. Number 12 asks, an Earth's magnitude can be determined by its what? So how strong an earthquake's magnitude, or how strong an earthquake is, can be determined by what? A, analyzing the seismic waves recorded by a seismograph. B, calculating the depth of the earthquake faulting. C, calculating the time the earthquake occurred. Or D, comparing the speed of P waves and S waves. Number 13, an earthquake occurs at 10:05 a.m. At 10:09 a.m., the first P wave from this earthquake is detected at a seismic station. Approximately how many kilometers from the epicenter is this seismic station located? Okay, so you are able to figure out the travel time of that P wave by looking at when the earthquake occurred and when that P wave arrived. Okay, figure out the travel time and use that to figure out how many kilometers from the epicenter the seismic station is located. Number 14, so you're going to base your answers on this. So it's essentially just saying no P waves or S waves are received in the shadow zone because of what? Because A, P waves are absorbed and S waves are refracted by the Earth's outer core. B, P waves are refracted and S waves are absorbed. C, both the P waves and the S waves are refracted, pushed away from the Earth's outer core. Or both the P waves and S waves are absorbed by Earth's outer core. Why aren't there any in the shadow zone? Number 15, the seismogram below shows the time an earthquake P wave arrived at a seismic station in Albany, New York. If the earthquake occurred at exactly 10 p.m., approximately how far from the earthquake epicenter was Albany, New York? Okay, so the P wave travel time is between 10 p.m. and 10:07 p.m. Okay, using that information, the P wave travel time, figure out how many minutes that is. Figure out how far from the from the epicenter this was. The epicenter distance. Number 16 says base your answers to the following questions on the diagram below, which shows models of two types of earthquake waves. Model A best represents the motion of earthquake waves called what? So what is Model A, P waves or S waves? That's the first thing you need to decide. So A says P waves that travel faster than S waves, or P waves that travel slower than S waves. Is Model A S waves that travel faster than P waves, or S waves that travel slower than P waves? You got to decide two different things there. Number 17. A strong earthquake that occurs on the ocean floor could result in the formation of what? So think the earthquake is happening in the ocean. This could end up with A, tsunami, B, delta, C, El Nino event, or D, ocean current. Number 18. Why is Earth's outer core inferred to be a liquid? Why do we think that it is a liquid? Remember, P waves can pass through liquid, but S waves cannot. Okay? So why do we think that the outer core is a liquid? A, P waves can pass through the outer core. B, P waves cannot pass through the outer core. C, S waves can pass through the outer core. Or D, S waves cannot pass through the outer core. Number 19. So you're going to base your answer on this cross-section below. It shows the type of seismic waves recorded at various locations after an earthquake has occurred. Point A is a location on the Earth's surface, and X is the epicenter of the earthquake. So it's saying point A is located 7,600 kilometers from the epicenter of this earthquake. How many minutes did it take the first S wave to reach point A? Okay, so we know the epicenter distance. How many minutes does it take for the S wave to get there? This is where my numbers get a little screwy. Number 20. Base your answer to the following question on the seismogram below. The seismogram was recorded as a seismic station and shows the arrival times of the first P wave and S wave from an earthquake. Which part of this seismogram is used to find the distance to the epicenter of the earthquake? How do you find the distance to the epicenter of the earthquake? A, P wave arrival time only. B, S wave arrival time only. C, the difference in the arrival time between the P wave and the S wave. Or D, the difference in the height of the P wave and S wave. Number 21. A seismic station is recording the seismic waves produced by an earthquake that occurred 4,200 kilometers away. Approximately how long after the arrival of the first P wave will the first S wave arrive? Okay, so you have the epicenter distance, and you're looking for the difference in time between the P wave and the S wave arrival times. So use your reference table. Number 22, a P wave takes 8 minutes and 20 seconds to travel from the epicenter of an earthquake to a seismic station. Approximately how long will an S wave take to travel from the epicenter of the same earthquake to this seismic station? So find where the P wave travel time on the graph is 8 minutes and 20 seconds. Okay, and then you're going to look to see how long it would take an S wave to get to that same spot. It's got a little duplicated here. Number 23. Base your answer to the following questions on the map and the modified Mercalli scale shown below. It shows the intensities of an earthquake that occurred slightly southwest of New Madrid, Missouri in December 16, 1811. The epicenter of the earthquake is represented by the asterisks, and the Roman numerals on the map show zones of the earthquake intensity determined by using the modified Mercalli scale. So we've looked at this before. Which location would probably have issued the report, "Many structures shifted off of foundations"? So you're going to look for that description. It might not be exact, but something that says that the structures are shifting off of their foundation. Which city is in the circle marked by that Roman numeral? Okay, it's going to be New Madrid, Syracuse, Pittsburgh, or Nashville. Number 24. An earthquake's first P wave arrives at a seismic station at 12 o'clock. This P wave has traveled 6,000 kilometers from the epicenter. At what time will the first S wave from the same earthquake arrive at the seismic station? Okay, so you have the epicenter distance. You need to find the difference between the arrival times and then add that time to 12 o'clock, okay, to figure out when the S wave will get there. And 25. So, you're going to base your answer on this chart. The distance from Albany, New York to the epicenter of this earthquake is 5,600 kilometers. So there's your epicenter distance. Approximately how much longer did it take for the S wave to arrive than the P wave? So you need to find the difference between the arrival times at this particular epicenter distance. Okay? And that's going to be your answer.